In this video, I'm going to go over some proportionality theorems, really just one, and then we'll do the converse of that proportionality theorem. All right, so first we're going to use our work with similar triangles from the last couple of lessons to prove that A over B is the same as C over D. Okay, so if I look at these triangles, CYA and triangle CDN, we're going to prove that those are similar right now. So they share this angle, all right? And then the other angle that I can say here is that these two lines are parallel, so I can use that corresponding angles are congruent for angle Y and angle D. So those two triangles are similar. And based on what we did with our similarity ratios, we could say that this length, A, over, and if I kept going, right, so add this extra part here, the YD, so that would be A plus B, has to be equal to the ratio of C over, if you kept going and added that together, it would be C plus D. All right, so I'm going to cross multiply here. Get A times C plus D equals C times A plus B. Distribute, so AC plus AD equals AC plus BC. You should notice that I have ACs on both sides, so I'm going to actually cross those out. Those are 0. So now I have AD equals BC. If I'm trying to get this proportion here, I'm going to divide this letter D over there and this letter C over there. Not letter C, Douglas, sorry about that. Letter B to the other side, my bad. This letter B over there. So the D goes this way and the B goes that way. So I'll have A over B equals C over D, which is what we started with. So this is how we're going to prove the proportionality theorem, okay? So I'm going to put that in the notes now. The triangle proportionality theorem, and again, I'm going to write the theorem here and make sure that you know that we're also going to have the converse, so just going the other direction of this. All right, so I'll draw a quick little triangle. So if I have a triangle here, and if I have, this is T, and this is U, and this is Q, and this is S, and they're telling us that TU and QS are parallel. If that's true, then these segments, all right, oh, I should label this one, sorry about that, label that R. Then these segments right here, RT over TQ is going to be equal to the ratio of RU over US. Okay, so that's what I'm going to write right now. Okay, so if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. Okay? Now, we're going to use this theorem in a couple example problems here in a moment. There is a theorem that's the converse of this, all right? So I'll write this out. This is the triangle proportionality theorem. So essentially, if segment TU is parallel to segment QS, then we can write RT over TQ equals RU over US. And so the converse of this would literally just be switching the order here. So you would say if the sides are proportional to each other, right? So if a line divides the two sides of a triangle proportionally, then it is parallel to the third side, so it's just going backwards, okay? So we'll use both, and then both will be on your theorem sheet. Okay, let's do 3 questions. I'm not going to do all the questions in these notes on the video. It would take too long, but please check Canvas for the key for the ones that I don't finish. Okay, so they're telling us to explain why GCD, GFB, and GAE are all similar, All right, so you can see those three triangles that are created here. And again, this is using that triangle proportionality theorem, right? You can see the parallel line notation. All right, so that's going to separate these triangles here. So we'll have this one and this one, these two here, and then finally the last two. All right, so those are all going to end up being have those ratios that we're going to look at. So I'm going to finish these fractions on this side. GC over CF. So GC over CF is equal to GD over DB. Then AF over FC is going to be BE over BD. CD over FB. All right, so CD over FB is going to be GD over DB. And then AE over CD, so AE over CD is going to be GE over GA. Okay, and then finally we have FG over AG is going to be FB over AE. Just ignore my dog. Okay, all right, let's do number 2. Number 2 says, these three lines are parallel, L, M, and N. Find the value of x. So this is using the triangle proportionality theorem, which is going to state that this x over this 2 is going to be equal to this 4.5 over this 3. Okay, this is probably the most basic way you would see it. All right, if you wanted to cross multiply, you get 3x equals 9 or x equals 3. All right, now number 3 is the last one I'm going to do. This is actually, I think, one of the more challenging ones. So keep in mind, like, these are the types of questions that we're going to want to put on quizzes and tests. All right, so looking at this one, it tells us AC, so this whole thing, all right, the whole thing is 18. So they're telling us that this is 6 stopping here, so then this is going to be 12 for that one there. Okay, AB, this whole thing is 15, and this one is x. So if I take 15 and subtract x, that would give me what's remaining for that A to that dot. Okay, so I'm going to find the value of x setting up the same kind of proportion that I did on number 2. So I'm going to have that 15 minus x over x is going to be equal to 6 over 12, right? That proportion. So 15 minus x over x equals 6 over 12. Now you can cross multiply now if you'd like. I am going to reduce that right side since that's 1/2. Make it easier when I do cross products. So 2 times 15 minus x equals x. So that's 30 minus 2x equals x. Move the minus 2x over with addition. So that'd be 3x or x equals 10. All right, so that is our value for number 3. Okay, now there's a bunch more questions for you to try, but all variations on this triangle proportionality theorem. All right, don't forget the converse does exist. I didn't write it in the notes, but check the key. I'll put it in there for you where you're going backwards. All right, come to office hours if you have questions. Check Canvas. Good luck.